Today we're looking at writing function rules and then ultimately using function rules to help us solve problems. When we're given a table like the one below, see how our values go up 1, 2, 3, 4 in x and go 5, 6, 7, 8 under f of x or y. We should ask ourselves, if I'm going to write a function rule, I'm being asked, how do I take the x's and turn them into the y's? So how do I get from 1 to 5? And how do I get from 2 to 6? The trick is I need a single rule that works for each of the points in the problem. So there's a few different approaches that you can take. Sometimes the rules are really obvious and they jump right out at you, and sometimes they're not as obvious. So if I'm thinking about how to get from 1 to 5, I might be like, oh, well, if I added 4, that would get me to 5. So then I would want to check that rule, and I would say, okay, then that has to work for 2. If I start with 2 and I add 4, hey, look, I get 6. And if I start with 3 and I add 4, I get 7. Notice that's following the pattern in the table. So in this case, the rule's not too bad. It seems like I take whatever my x value is and I add 4 and it gives me the y value. Notice it even works here. I start with 4, I add 4, I get my y value. So once I realize how I can take each x and turn it into y consistently looking down the table, I'm ready to write a rule. The way I get f of x is to take x and add 4. Now, we can also write function rules from a scenario, a situation, instead of writing them from a list of possible values. So we're going to look at a couple of those together. Our first problem says, a carpenter buys finishing nails by the pound. Each pound of nails costs $1.19. Write a function rule to describe the relationship. And then once we have the function rule, we're going to be asked to use that function rule to try to calculate a new cost. How much will 12 pounds of finishing nails cost? There are some different approaches that we can take to do this. Some students can read the problem and just write the function rule. They can just see it. Other students, it really helps to think about some concrete examples first. So I'm going to start with that approach since this topic is new to us. So I'm going to create an XY table, but we have to think about what's the input and what's the output. So it says the carpenter buys finishing nails by the pound. So the number of pounds will determine the total cost. So that means our X is the number of pounds and our Y is the total cost. So if we bought no nails at all, it wouldn't cost us any money. If we bought 1 pound of nails, since each pound costs $1.19, it would cost us $1.19. If we bought 2 pounds of nails, we need to think about how we do that. Well, it seems like if every pound costs $1.19 and we buy 2 pounds, we probably want to multiply those two things together, and it would cost us $2.38. So that lets us kind of generalize a little bit. If I had X pounds of nails, I would take the $1.19 for 1 pound and multiply it by X pounds to get the total cost of buying all the nails. So when we go to write the function rule, we're going to say f of x, or you could use y, will be equal to $1.19 times x, where f of x is the number of pounds. X is the number of pounds, and f of x is the total cost. So part B asks us to use that function rule. It says, how much will 12 pounds of finishing nails cost? Well, that means calculating f of 12, which means substituting 12 for x in our problem. When we multiply $1.19 by 12, we see that it's going to cost $14.28 for that total purchase. So the answer to part A was our function rule, and the total cost is the answer to part B. We have a second word problem to look at together. It says you can estimate the temperature by counting the number of chirps of the snowy tree cricket. The outdoor temperature is about 40 degrees more than a quarter of the number of chirps the cricket makes in 1 minute. What is a function rule that represents the situation? All right, there seems to be a lot of information here, so it really might help to kind of look at a table of values, start with something concrete before we try to go to something kind of abstract, which is coming up with a function. So if the temperature outside was 0 degrees, then it says the outdoor temperature is about 40 more. So that would mean adding 40 to something. Then, oh, actually, let me back up. I'm not starting you out the right way. Let me try that again. Let's talk about what X and Y stand for. Always think about what's your independent and what's your dependent. So it says it's 40 more than the number of chirps. It says we can count the number of chirps to figure out what the temperature is. So the number of chirps is going to be our input. Our output is going to be the temperature. That's what we are supposed to be able to figure out by counting the number of chirps. So let's think about what would happen if we heard it chirp. Well, we might want to say one time, but I have to take a quarter of the number of chirps. So kind of like in one of the problems we did on a previous lesson, we had to take a half of something, so we decided to only pick even numbers. Now we have to take a quarter of something. Well, the easiest numbers to take a quarter of are numbers that are divisible by 4. So let's say the cricket chirped 4 times. It says 40 more than a quarter of the number of chirps. So a quarter of 4 chirps plus 40 degrees should be our temperature. Well, we know that a fourth of 4 is 1, and 1 plus 40 is 41. If there were 8 chirps, I would take a quarter of those 8 chirps, which is 2, and add that to the 40, because I'm supposed to have 40 more, and it would be 42 degrees. I'm already sort of seeing a pattern. If I had X chirps, I could take a quarter of those X chirps and add 40 to get the temperature at any time. So the function rule for temperature will be 1/4 times the number of chirps plus 40 degrees. That's our function rule.